Okay, welcome back. This is the next video in my Linux for Beginners series. We're going to talk about file and folder permissions a little bit. At the end of my last video, I mentioned it. This is how you control who can access what in your server. And this is important for system admins. At a small company, your DevOps team is usually the one that kind of does everything. At an even smaller company, the lead developer might be the one doing these things. So it's important stuff to know. And it's good just to kind of understand the principle. So let's say that you work at a company and you have two developers, Anna and Jeff, and you have two people on the DevOps team, Pierre and Frank. And let's say that you want to set up a server so that the developers can get in and see the code and change the code. And the DevOps people, they just want to have access to everything. So that's kind of the purpose behind the permissions and for the files and folders. And this is a really simplified example, and it's maybe not a great real world example because your developers probably shouldn't be modifying code directly on the server in real life, but this is just a way to illustrate the principle. So let's talk about for a second what the permissions look like. So the ls command will show you all of the folders and files that live within the directory that you're currently in. And I'm in my current user's desktop directory. So ls will show me the folders and files, and ls-l will show you all of those same folders and files, but it puts each one on its own row, and it shows you a whole bunch of other information. So you can see the size, like how many bytes the folder and file is taking up. You can see the owner of the folder and file. This is the user that owns it, and this is the group that owns it. And if you're unfamiliar with the idea of groups, you could think of it like the team, right? We can have it so that the developer's group owns a folder. Since each folder and file can only have one user owner, then what you can do is you can assign it a group owner, and then everybody who's part of the group will be able to have the permissions for that file and folder. And then this last thing shows you the permissions, and that looks like a bunch of garbage, but it's actually pretty simple. So let me show you what it's indicating. The D or the dash just means if it's a directory or a file. So you'll see that the files have a dash, the directories have a D. You don't have to worry about that too much. The RWX, those are permissions for read, write, and execute. So that's if you have the permission to read or see what's in a file or folder. Write would be the ability to edit or modify what's in a file or folder, and then execute is the ability to execute, which some files are executable, like if you have a program. Like if you write a Node.js program, when you do node index.js and you're running your program, that's the ability to execute that file. And it kind of lumps them all together in this big long string, but it's actually broken down into three separate things. So the first three, read, write, execute, is the user's permission, the user that owns it, which in this case is me. The second group of three is the group. So whatever group owns that file, you can set specific permissions for what that group has the ability to do. And then the third one is everyone else on the system that's not the user or the group that owns it. And I'm going to put this in parentheses. I'm going to say others, other people on the system. So back to our example here. Let's just say that we also have some other people on the server, which, once again, probably not great security practice. If people don't need access to things, they shouldn't be on the server. But let's say that maybe you have a QA person, and so I'm actually going to call this the QA team, and maybe they have some stuff. Maybe they have a QA folder, and they need to be able to get in there and do stuff. Maybe we're really pushing the boundaries here. Maybe you have a sales team and you have a salesperson who needs to get on and do stuff. Okay, so the point is you have the user that owns the file, you have a group that owns a file, and then you have other people on the system. And what should those other people be able to do? And that, sorry, this is skipping all over. That's what the third set of read, write, execute permissions tells you to do. So if you see something that looks like this, it's saying the user has read, write, and execute permissions. The group has read and write permissions, but no execute permissions. And everyone else on the system has read permissions, but no write or execute permissions. So it's pretty simple to read it when you start seeing it like that. So let's modify some of these permissions. And the way that you do that is with the chmod command, chmod. And you basically say what you want to change, and then you say what file you're targeting. So the shortcut for these is going to be U for user, G for group, and O for others. So let's say I want to give the user that owns this file execute permissions. So I would say user, I want to add execute permissions on test3.txt. Oh, it's sudo with an S, not a C. And that stands for super user do. So it might be pronounced sudo instead of sudo, but I say sudo. It looks like sudo to me. All right, so you'll see that I told it to add the X to the user's permissions, and that's what it did. Let's say I want to take away the read ability for other users. I would say sudo chmod for other users minus the read ability, test3.txt, and it's gone. Let's say I want to add all capabilities for other users. I would say sudo chmod other users add read, write, and execute permissions. And there they all are. So you can target the specific user group or others on the system. And you could do it for everybody. So I could say target the user, the group, and others, and take away everything, read, write, and execute. Oh, maybe you can't do them 3 at a time. I was wrong. Okay, so this is where the little trick comes in. So instead of targeting, if you're going to target all 3 groups, you can use the letter A for all. Oh, maybe not. Oh, it's because I didn't do the chmod. Okay, hold on. That's my bad. There we go. So I targeted all 3, user, group, and others, with this A flag, and that got rid of everything. And now that I realize I forgot the chmod, let's see if this will work. Okay, it looks like that's working just fine. So let's add it all back in now. So you can do sudo chmod for all 3 groups, add read and write permissions. Awesome. And that would be the same as doing this A flag. Instead of targeting all 3 groups individually, you could target it all with the A flag. Okay, so that's how you change the permissions for a folder and file. You might also sometimes see people doing this, these numbers. And those numbers are doing the same thing. They're updating the permissions. The first number represents what permissions you want for the user. The second number represents what permissions you want for the group. And the third number represents the permissions you want for others on the system. So you could do sudo chmod 770, and that's going to give you read, write, and execute permissions for the user and the group, and no permissions for the others on the system. Okay, so 7 means all permissions, 0 means no permissions, and then the numbers 1 through 6 also mean other things. And the way that that is done is 0 is nothing, 1 is just execute permissions, 2 is just write permissions, 3 is write and execute. And I'm going to explain how this works in a second. 4 is read permissions only, 5 is read and execute, 6 is read, write, and nothing else, and then 7 is all 3. And the reason that these numbers work like this is because this is counting in binary. So let me show you what I mean. If you count to 10 in our normal system, it would go 0, I'm going to go down a cell here. 1, 2, here we go. And then when you get to 9, the next number is 10, but we don't have a symbol for 10, so you just change it back to a 0 and you stick a 1 in front of it. Right? And this is how we count. 11, 12. And then once again, we don't have the symbol for 10, so you're going to change the 9 to a 0 and then stick a 1 in front of it. Or really what we're doing is we're increasing the 1 in front of it by 1. So the 19, this would become a 0, and then we'd increase the 1 in front of it by 1. And you can do that all the way up until you get to 97, 98, 99, and then we make this one a 0, we increase the next one by 1, but that makes that one a 0 and increases the next one by 1. So you put a 1 and 2 zeros. So this might seem silly that I'm explaining how to count, but if you've never counted in binary, it's good to understand what's happening when we count. So in binary, there's only 2 digits, 0s and 1s. So you don't have a symbol for 2. So you do things a little bit different. So a 0, I'll just start with a 0. You have a 0, and then you have a 1, and then you don't have a symbol for 2, so that the 1 turns into a 0, and you stick a 1 in front of it. So that's the number 2 in binary. 3, you increment by 1. 4, we're going to increment by 1, but we don't have a symbol for 2, so that becomes a 0. The next one becomes a 0, and we stick a 1 in front of it. There's 5, 6, 7, 8. Okay, so this is how you count in binary. And you'll see people sometimes put leading zeros just so that, oh, Excel doesn't like my leading zeros. It's getting rid of them. That's fine. But if you see something like this, that's the same thing as 0. They're just, if you put the leading zeros, then you can represent all 4 digits all the way down. But it's the same thing. So 0, 1, 2, 3, 4, 5, 6, 7. So this is what's happening is imagine that for each of the 3, read, write, and execute, if the letter is there, that's the same as it being a 1. And if the letter's not there, it's a 0. A 0 means off, a 1 means on. So a 0, they're all zeros, and there's no permissions. A 1 would be 0, 0, 1, which would look like this, dash, dash, execute. So you'll see now that this is maybe going to start making sense. A 2 would be 0, 1, 0, so that would be dash, write, dash. See, that's the 2. And with a 3, it would be 0, 1, 1, and so you'd have a dash, and then write and execute. So maybe this is starting to make more sense now. With the 4, it's 1, 0, 0, so you'd have the read and then 2 dashes. This one, the one in the middle is a dash. For 6, the first 2 have letters, and the last one's a dash, and for the 7, all the letters are there. So that's how these numbers came to be. Whoops. And you can use, when you're changing permissions, you can use either approach. If the numbers make more sense to you, feel free to use them. There's other ways more maybe user-friendly for a lot of people, because you can just target, I want to change the user's permission, and I want to take away execute permissions. Oh, and once again, I forgot my Chmod command. So two different ways to do the same thing. And then this is where you can see who the user is that owns the file and who the group is that owns the file. My mouse is doing weird things. There we go. So if you want to change the owner of the file, you do that with the sudo, well, I'm inside of my user's home directory, so I don't know that it'll actually let me change the owner of a file. Let's switch gears for a second. Let's talk about how to get users on the system, and then we'll come back to changing the user and group who owns the file. So let's add these users to the system. We want users Anna, Jeff, Pierre, Frank, Molly, and Andrea. So we can do that sudo add user. I'm going to pull this over to the side so I can see it a little easier. Okay, Anna. And you'll notice it's going to ask what password I want for Anna. This is adding a user in the sense that this user could log into the server with a password. And that may not be what you want. So there's another command I'll show you in a second that's a little different, but for now, oh, you have to type something. So maybe you have them set a password or copy in some random string. I don't know. I'm just going to type her name as the password for now. Okay, what's her full name? I'm going to leave these blank. So now if I go to the home directory in root and do ls, you'll see that it added this user Anna. And let's add another one. Let's add Jeff. So now I have these other users. And the other command that you can do, instead of add user, you can say user add. Let's do that one for Pierre. You'll notice that it doesn't ask for a password and it doesn't create a folder for them in the home directory. But the user did get added. And if you ever want to see what users are part of your system, there's a file in the root directory. There's a folder called etc. You'll hear people call it etc, etc. And then there's a file in there called password or passwd. And if you cat that file, cat, I didn't go over that command, but it just lists the contents of a file. This will list all of the users that exist in the system. So I have these 3 users that I just created, Anna, Jeff, and Pierre. Let's add another one. Let's add Frank. Let's add Molly and Andrea. Okay, so now if I do sudo cat etc password, here's the file that shows all of the users in the system, and these are the ones that I just added in. If you ever want to remove a user, let's say that let's say Andrea quits. It's user del, user delete, user del, Andrea. And that removes the user from the system. So now if I do sudo cat etc password, she's gone. No more Andrea. So that's how you add and remove users from the system. Now let's talk about groups. I want to add a group called developers and another one called DevOps. So sudo group add, I think. Let's see if this works. Developers. Hey, it worked. Okay, and then the file that shows you all of the groups for the system is in etc, and it's just called group, singular. So once again, that's sudo cat etc group. And you'll see that for each of the users I created, it creates a group for that user. And then you can create other groups as well, and we can add users to these groups. Okay, so let's create the other group, DevOps. And now if we cat the etc group file again, you can see that we have our developers group and our DevOps group. That's great. So now let's start changing permissions for things. So I'm going to go back into my desktop. And this is the desktop for my user's home directory. I'm going to try and change the group and see if it lets me, but I don't know if it will because it's my user's home directory. I'm actually not sure about this. This is something I have never tried before. So the way to do it is the change owner, CHOWN, sudo, people call it chown, change owner. And you have to say what user you want to own the file and what group you want to own the file. So let's say I still want Lauren to own the file, but the group is going to be developers. Oh, it totally let me. Okay, well, you learn something every day. Okay, so it let me change the group ownership of this file to developers. Let's say I want to make Anna the owner. And there you go. You'll see that it lets you change the user and the group that own this file. So now the user Anna would have read and write permissions on this file. Any user that's part of the developers group would have read, write, and execute permissions on this file. And everyone else in the system can do nothing on this file. And this is really the one that you want to watch, this last one. Because you can assign a user and a group to own a file, and then it's fine if they do things to that file or folder. But anytime that you have full permissions on this other category, that means anybody in the system can do anything they want to that file. So a good example here, anybody in the system can read this file or this folder. They can see what's in the folder, which maybe you want, maybe you don't. I don't know. But let's keep going with this real life example for a second. Let's say that this is a production server, and inside of your root directory, maybe you decide that you're going to have a folder called code. So sudo make directory code. Oh boy, misspelled it. Okay, rm-r cowd. That was the wrong name. Make directory code. Okay, so here's my code folder. And let's say that all of the code for your production server is going to live in there. So I could do ls-l, and we can scroll up till we see the code directory. We can see that it's owned by root, and then we can see the permissions on there. So I want the developers group to own that folder. So I'm going to do sudo chown and I don't know that it matters what user owns this folder. I don't do system admin stuff for a living, so there could be a good reason to change that, but I'm not aware of it right now. So I'm just going to leave root as the user that owns it, and then the developers group will be the group that owns this folder. So I'm going to change the permissions for the group so that it can do whatever it wants in there. So chmod. For the group, I want to do all permissions on code. Now ls-l, and you'll see that the group has rewrite and execute permissions. And I don't want anybody else to be able to do anything in that file or folder. So others minus everything. Okay, so this is starting to shape up. The root user owns the folder, the developers group owns the folder. Either of them could do whatever they want in the folder, and everyone else can do nothing in the folder. That sounds great to me. So now let's make sure that the right people are part of the right group. So I want to add Anna and Jeff to the developers group. So you do that with the Chmod Command. And then you do this dash lowercase a dash capital G. I don't do this often, so I have to look it up each time. How to add user to group. Group name and then username. So the group name is developers, and the user that we want to add, Anna and Jeff. I think it'll let me do two users at once, but let's find out. Nope, I was wrong. Okay, let's do them one at a time. Let's add Anna. Oh, and that makes sense because I'm doing a Chmod command. So I think you can list multiple groups, but only the one user because it's a Chmod command. Okay, so we're going to do the same command for Jeff. So now Anna and Jeff should be part of the developers group. And if we cat the etc/group file, you'll see that the developers group lists those two people after it. Okay, so let's do sudo usermod -a capital G. We want to add to the DevOps group Pierre. In your terminal, if you hit the up arrow, it'll go back to the most recent command that you did. In fact, if you keep hitting the up arrow, it'll cycle through the commands that you've recently done. And the down arrow goes back down through them until you end up back at the empty blinking cursor where you can type stuff. So I'm just going to hit the up arrow and then change Pierre to Frank, since I want both of them to be part of the DevOps group. Now if I come back up here and list the groups out, I have the right people in the right groups. Okay. And now Anna and Jeff should have access to that code folder because they are part of the developers group. So let's test that out. The way that you'll see here that I am signed in as Lauren, and then it tells you what computer this terminal is connected to, and right now it's connected to my VirtualBox machine, which makes sense. If you, for instance, if you're on your computer and you have your terminal open like this, and then you SSH into a server, this name will change to the whatever server you just SSH'd into. So the way that I'm going to do this is I'm going to switch users. So sudo -u, I want to switch to the user Anna. and then I'll just type bash, and that says open me up a terminal prompt as Anna. So it started a bash session or opened up. Basically, I'm still just in the terminal, but now I'm in the terminal acting as Anna. And if you type exit, it'll exit that session that you just created, and it'll go back to what you were doing before. If I type exit again, this is where it started. So if I exit from here, it's going to close the terminal out. But that's fine. I can get right back in. And then let me make this bigger for you again. Is that too big? I don't remember where I was at. Let's size-wise. Let's start here. Okay, so sudo -u. I want to be Anna, and I want a bash session. Because I'm using sudo, it's going to make me type my password. That's fine. It wasn't making me before because I'd already typed it at one point, and it keeps track of when you've typed it. So now I'm acting as Anna. So if I cd to the root directory, and I try and cd into the code directory, it lets me. It lets me come in here. I can touch a file because Anna has permissions because she's part of the developers group. Okay, ls-l will show you all of the things inside of the directory as well as their permissions. ls and then -la will also show you these extra ones. So this is saying the current directory that I'm in, what are the permissions, and you can see that. And then the parent directory, which in this case would be the root directory, what are the permissions for that directory? So sometimes it's nice to see those two things. In this case, if you want to see the permissions for the directory you're in, instead of having to like cd up a level and do that, you can just do ls-la and it'll show you right here. So because Anna's part of the developers group, she has full permissions inside of here. Okay, now let's do this. Let's do sudo chmod 7, let's do 000 file.txt. This isn't going to work. Sudo is a group, and Anna does not have a sudo password. Anna does have a password. It's her name, Anna. But Anna is not part of the sudo group, and it'll log that she tried to do some sudo stuff somewhere. So my user, Lauren, is part of the sudo group because this is my machine, and Lauren's the user that it created when I created the machine. But I have not added Anna to the sudo group, so she can't do sudo things, and that's important. You want to make sure that the only people that have sudo access are the ones that should. Okay, so Anna has access to the code directory. I'm going to exit and go back, and now as Lauren, I can be a different user. I'm going to sign in as Molly. Molly is in the QA team, but she's not part of the developers group or the DevOps group, and she shouldn't have access to that code directory. Okay, so now I'm signed in as Molly. Let's cd to the root directory, and let's try and cd into code, permission denied. Okay. Molly's not part of the developers group, and it's not the root user, it's the Molly user that I'm signed in as, so she has no permissions. Okay, so that is how you modify the owners of your folders and files and modify the permissions as well. I'm trying to think if there's anything else. I showed you how to remove a user. Let me show you how to remove a group. Let me exit back to my user. Sudo group add test. And now if I do a cat on the Etsy group folder or file, you can see that it created this test group. But let's say I want to get rid of that group. It's sudo group delete and then the name of the group. Now if I cat that file back out, that group's gone. So that's how you add and remove groups, add and remove users. I showed you how to add users to a group. Real quick, I'll show you how to remove a user from a group. Let's say that Jeff quits, but I don't want to delete the group. I just want to remove him from that group. I actually have to look this one up. Okay, so how to remove user from a group. Sudo password -lowercase d, and then the username is Jeff, and the group name is developers. What did I do wrong there? Oh, gpass. This first part has a G on the front of it. Sudo gpasswd. Removing user Jeff from group developers. So now if I cat the groups out again, you'll see that Jeff is gone out of there. Let's say that Anna should have access to both the developers group and the DevOps group. You can add her to more than one group. That's fine. I want to add Anna to DevOps. Oh, did I do that backwards? I did that backwards. Now if I cat that group folder back out, you'll see that Anna is part of developers and DevOps. So that's how you add and remove users from groups. We've talked about the permissions and the ownership and how to change those. And I think that's basically it. Hope it was helpful for somebody, and I appreciate you watching.